Hello everyone, I am Priyam and I welcome you to Phase. You're currently watching the 7th episode of the AnyBody Can Code series. To view previous, next, or start from the very beginning, check the links in the description below. In the previous episode, we continued learning about conditional statements in C. We discussed nested if, relational operators, logical operators, and ternary operators. In this episode, we'll create a calculator using conditional statements and then go on to learn about switch cases. Finally, we'll recreate the same calculator using switch cases. So without further ado, let's get coding. Using conditional statements, create a calculator which takes two numbers and one basic arithmetic operator as input and returns the result as an output. Let's begin by planning our code. Firstly, we require two float variables for input and we need another variable for output. We also need a character data type variable to input the operator. Then using an if-else ladder, we can compute the required equation based on the input operator. Finally, we'll print the result. Now that we have finished planning, let's get coding. I'll use the same online compiler. So I'll remove the unnecessary parts and I'll quickly begin to code. Now we need to prompt the user to enter the operator according to the operation required. So my calculator will only have the basic operations. You can use math.h and add other operations if you want to. %c is a placeholder for character data type. It's similar to %d that represents integer and %f which represents a float variable. Recall that the variables are containers that store values. Data types are filters that determine which type of value is supposed to be stored. %c helps store the ASCII value of the input operator. ASCII value is a binary code used by the computer to recognize a character. For example, when you type A in your laptop keyboard, then the computer reads it as 011000001. This is 61 in hexadecimal value and 97 in ASCII code. We'll further discuss this in future episodes. Another thing to note is the comment written in line 9. I have left a space before %c. I'll explain this why it's very necessary after finishing this code. For now, let's get back to coding. Using the double equal to relational operators, I am checking whether the value stored inside the variable c is a plus operator. If it is, then the sum of the variables a and b will be stored inside a variable called result. Now let's do it for the other input operators. With this, we have covered all the 4 possible operations. Now let's consider a possibility where the user inputs a wrong value. The goto statement is a cheat code in C programming, which allows us to overcome the sequential flow of the logic in C language. It is advisable to code without relying too much on the goto statements. We will understand goto statements in detail a bit later. Now, let's just print our result. Notice the usage of the local keyword skip. With this, some of you have probably guessed how a goto statement works. Now let's run this code and find out whether the calculator that we built is working properly. Let me begin by giving an incorrect input. Oh, before that, I need to select the language. So C programming, I'll just give 265 and 58. So now I have to give the operand, and like I said, I'll give an incorrect value. So let's say I'll put percentage instead. It's telling me this basic calculator can only perform addition, subtraction, multiplication, division. Run the code again with the correct input. So our code is working correctly till now. Let me try it again with a correct input this time. I'll use 7 and let's say 2. Let's divide the numbers. It's giving me 3.5, which is correct. Before we talk about the goto statement, let's quickly understand the flow of power through our code. Once the power reaches line 10, the if condition checks whether the ASCII code of plus symbol is stored inside the variable C. If the condition is true, then line 11 gets powered up, and the sum of the variables A and B gets stored in the variable called result. Then the power jumps to line 23, ignoring all other lines. Finally, line 25 gets powered, which ends the code. But if the if condition in line 10 fails, then the power jumps to line 12, completely ignoring line 11. This continues until one of the conditions in line 12, 14, 16 is satisfied. If all conditions fail, then eventually the power reaches line 18. The power then executes the printf function in line 20 and then flows to line 21. Due to the goto statement in line 21, the power jumps to line 24, completely ignoring the printf function in line 23. And that's how we get the correct output. Here the goto statement basically creates a local keyword called skip. It makes the compiler look for the word skip in the entire code. and then powers the line which are below it. Some of you might be thinking, why am I using the goto statement? Let's remove it from our code and see what happens. So I'm just removing the goto and the skip. Now let's run this code. It will still work correctly except one case. And as you would have guessed, that case will be when we give an incorrect input. So let's say 5. Now look at the output here. Line number 23 is also getting printed, but I obviously don't want to print it, and that's why I use the goto statements. So I'll just use Ctrl+Z to bring it back. The local keyword can be placed anywhere in the code. It can even be above the goto statement itself. Let's quickly write a very small code to demonstrate this. Write a code which performs a looping action without using the looping statements such as for, while and do while. Let's see what happens when I execute this code. I keep forgetting to select the language. Basically, looping happens. Once power reaches the 6th line, the condition in the if statement gets satisfied. This is because a is equal to 0, which is less than 5. Now line 8 gets powered and the value stored in the variable a becomes 1. The power flows to the line 9 and it prints a equal to 1. Once the power flows to line 10, the goto statement commands the code to look for a local keyword called looping. Looping is found in the 5th line. Thus the power jumps from line number 10 to line number 5. It goes up. Line 6 is powered again and the process repeats as the value in the variable a is still less than 5. Thus the block of code inside the if statement gets executed 5 times and the line 9 gets printed 5 times. Obviously, the value of a is incremented in each cycle. This is a special case as looping is usually performed with a looping statement like for, while or do while. We'll learn about these in a later episode. Now, let's get back to our simple calculator. In the 9th line, I intentionally left a space before %c. Let's see what happens if I forget to do so. So I've removed the space and now I'll run the program. It asks me to enter 2 values. Okay, it's working fine till here. But it falls apart from here. You can see that the scanf statement in the line 9 didn't get executed at all. The power jumped from line 8 to line 10 as the value inside the variable c is a garbage value. None of the conditions are met and the power keeps jumping from line 10 to 12 to 14 to 16 and finally to line 18. The else condition is satisfied and the printf statement in line 20 gets executed. The power then flows to line 21. The goto statement makes the power jump to the line 24 and then to line 25. Thus the failure of scanf function of the 9th line causes the entire code to fail. But why did the scanf function in the 9th line fail? Well, the scanf statement is reading a character data type variable. While doing so, it will also consider the entire key which we have pressed after we input the values of the variable a and b in the scanf function used in 7th line. Thus, we need to leave a space before it. This is very important point and you mustn't forget it. This is another important thing that you need to remember. It is called implicit conversion. Some of you must have noticed that the input values were all integers, but the data type that we have put in the code is a float. Let's see what happens if we use data type, integer data type instead of float. So I'll put the space back and I'll just use int. So I'll run this code and see what happens. Okay, I'll again use 7 and 2. Let's use division operator. It's giving me 3.0. So you can see that instead of 3.5, we are getting just 3. This happens even though the variable called result, which stores the value, is of a float data type. Let's understand why this happens. Consider the statement C equals to A divided by B. Here A equals to 7 and B equals to 2. As both are integers, the value stored in the variable C will also be an integer. But we have defined C as a float data type variable. So the computer will simply add 6 zeros after a decimal point. This is obviously incorrect because 3 is not equal to 3.5. The concept of implicit conversion is of great importance and might be the thing that fails your code. So please try to remember this. Moving on, just as we did in the previous episode, let's improve our code for a simple calculator. We will do so by using the switch case. Switch case is another conditional statement which is very similar to the if-else ladder. Instead of talking in length about its syntax and advantages, let me allow you to show you through a code. So I'll quickly delete the unnecessary part. So my switch case will begin from here. I have already prompted the user to input the values and taken it through scanf. Now this is for plus. I need to repeat it for all the other three operators. Finally, if none of the cases are satisfied, I need to give a default output. Now I'll just simply print the result. So I have quickly changed the data type of my code. So now that my code is ready, I'll quickly run and see the output. Again, we have the same, enter two values. I'll take two random numbers. Let's take multiplication this time. and it's giving me a value, which is correct. As you can see, the switch case is almost the same as an if-else ladder. As we need to perform an arithmetic operation based on the value stored in the variable c, it becomes the argument of the switch case, as you can see in line number 10. The 4 cases and 1 default case are similar to the if-else ladder. If the value stored in variable c is the same as the cases, then the code of block below it gets executed. Let's look at the flow of the power through the code to understand the switch case better. The power flows normally until the 10th line. Once the power reaches the 12th line, the ASCII value of the plus symbol in the line number 12 and the ASCII value of the character stored in the variable c are compared. If they match, then the power flows to the line number 13. The sum of the variables a and b is stored in the variable called result. The power then moves to line number 14. The keyword break ends the switch cases and makes the power jump to line number 28. The printf function in line 28 then prints the result. But if the ASCII values of the character stored in variable c and of the plus symbol in the line 12 don't match, then the power is transferred to line 15, completely ignoring line 13 and 14. This continues until a case passes. If none of the cases pass, then the default case in line number 24 is executed. Line 25 is powered, followed by line 26. The goto statement in line 26 makes the power jump to line number 29, completely ignoring line 28. Finally, line 30 ends our code. With this, we have come to an end of this episode. Other than switch case and the goto statement, you need to remember 2 important points that we have discussed in this episode. First, always leave a space before %c in scanf functions, especially when there is another scanf function just before it. Second, while dividing, keep implicit conversion in mind and use a float data type. There are other ways to overcome this problem, but we'll discuss them in a later episode. In the next episode, we'll begin learning about looping statements. So stay tuned.
Hey YouTube, how are you doing? Stay tuned to Facebook for more awesome videos. Don't forget to subscribe.